This is the video over Wireshark 101, and it just talks about how Wireshark is used to create and analyze PCAPs, which are network packet capture files. Um, so it just talks about just understanding what we're going to use and stuff like that. You have to install it. Since I was going to use the attack box already has it. And either way, if I was going to use my VM, it already has it because it's a Kali. The next VM, or I could have had it on my computer, but I just wanted to use the attack box because it already has something here. It already had everything I needed. So the next one is talking about how to basically use it, how to start using Wireshark, and that there are um, two types of work boards that work with Wireshark, which is uploading PCAPs for analysis or performing a live capture. Now, live capture, of course, collects all the network traffic and converts it to a human-readable format, which allows to be more usable, to get more usable information out of it. And it's very effective because of the important things that it has: the packet number, the time, the source, the destination, protocol, length, packet number. Like, it has a lot. Like, it gives a lot of information. So it's nice to be able to see all of that in work, and especially when we talked about it in class and being able to see it in class in a real life demonstration was very nice to see. We were going to talk about network taps, port mirroring, MAC flows, and ARP poisoning. And you usually have to start with a sample capture. Make sure that you have enough power to handle the number of packets you want to use because of the size of the network and have enough space to store all the captures. Network taps, it connects between two tables and intercepts the traffic. Max, it is designed to break the network switch security and by stressing the switch and filling the cam tables. The ARP poisoning, it diverts the traffic to its own monitoring machine. So, poisoning, I love little catchphrases to think of. It's always amazing to know those. Then we learn about filtering, how to filter based on different protocols with different syntax you would want to use for you to only get the information that you're wanting, because it's a lot if you really go through it. Then you have to talk about packet, the different layers of the OSI model. So you have to know all the different layers because that's how you'll know where each part goes. So of course, layer 1 is the frame, layer 2 the source, MAC, layer 3 is the IP source, layer 4 is a protocol, then there's a protocol errors. It's important to be able to read all of this. Layer 5 is the application, and there's an extension, the application data. I'm just learning to know the different protocols, the different layers. This is when you get to start doing it. Okay, so this is where you do the ARP one, which is layer 2. and it is used to connect IP addresses with MAC addresses. And you use the data linked layer, and it uses a request, which is a request one, and a response, which is reply two. It usually you want to see what who rather if it's the packet that's requesting or if it's a response or reply packet. Usually you can tell because it will tell you it's either a request or it's a reply. So you, of course you just answer questions by looking at just doing task 7. Then you do ICMP traffic. Next, ICMP traffic. In the ICMP traffic, it's analyzing multiple network nodes, and usually that's ping or trace route. I think I think that's right. I think that's what we talked about in this one. It's ping, it's trace route, things like that. And it's usually for errors to see if you have any errors coming back whenever you get it. So whenever you get a number 8, that is the request. 0, that's the reply. And you always have a timestamp that tells you the date and the full data string that comes with all of this. Then TCP traffic, which is managing the packet delivery. It was basically just reading through the space, understanding what TCP packets are, and just the different structures, the behaviors that they come with. Just being able to read and understand what you're reading is basically what this is. And the most important thing is that it needs to be looked up as a whole, not by one, because you don't really need to go into details. Next is the DNS, which connects names to IP addresses, which is we talked about slightly in class about what that is. And you have the DNS query, the rule of thumb, the DNS response. Usually 53 is pass, UDP 53 is pass, TCP 53 is suspicious. Rule of thumb, always try to be aware of everything. Literally. When it comes to this, you have to be aware of everything, and the response is the same as when you get in a query packet, just getting past the response, and it has the answers at the bottom, which is what that said right there. Next is the HTTP traffic, which is what is used to access a website, but it's less encrypted because it has no S. It's not. You get and post requests because it is web pages. So usually you have to know about web shells, other different attacks, SQL injections, not SQL injections, which are very important. The most important things to gather from this is that you request, you are you have a response, you have a host, you have a user, an agent, you have a file data, and you have a server. Making sure all of this is included and they all have a hierarchy because you need to know the differences with each capture. Then you have to try to organize everything and see if there's any discrepancies whenever it comes to it. And we just first questions. HTTPS. This one is the secure version of HTTP, which which is very well known. So there are three ways to create a secure tunnel. First one is that the client and server agree on the protocol type, then the client and the server also select a cryptography algorithm, whichever cryptography algorithm that you pick. Usually SSL certifications are probably the biggest one. Then the client and the server must authenticate to each other. Authenticate, which is being able to know that the public key for them to be able to encrypt the other message. Then you have to create a secure funnel, which means at this point everything should be encrypted or based on what you decided to encrypt. That. Then the traffic between them is now encrypted. That's why you have a jumbled letters and words, letters and numbers, all in that. And so then you just follow the instructions and just look and see, just read through it, to be quite honest. It's a step-by-step process. Next is the zero logon PCAPs. Zero logon is when a attacker uses net logon remote protocol to have a vulnerable net login secure cat channel connection to a domain controller, which allows them to elevate in their privileges, which makes it a vulnerability that is very scary. And usually they do endpoints and they go laterally. You have to go up. And they usually try to make a defect in the cryptography authentication system, which is what we just talked about. So usually you have to identify the attacker, and usually you can do this with just looking at the unusual activity and seeing if there's something out of the norm. Usually by looking at OpenVPN, ARP, DC, ERPC, or EPM. Usually that's something out of the norm, and then you can filter out for that one. Then, once you do that, make sure that there are specific exploits that they've done that they carry with them. Then you can do secret dumps, which basically means that each exploit and attack has its own set of fingerprints that will always be clear on what happened in the order of the events. So the main thing that you're wanting to do is identify and isolate the incident and then report it to the designated team. And the conclusion is just learning more about Wireshark and why it's important. Either way, this it's long because you might have to read. So because I wanted to do my own time, so I ended up spending a lot of time on this. But which it took 60 minutes, but honestly I think I spent longer. But that was because each part that allowed you to literally see into it. I didn't want to look at step by step. Sometimes it didn't tell you step by step, so that's explanatory. But whenever it gave you step by step, I didn't really want to do step by step because then I'm not learning. So I just did one by one, and if I got stuck, that's when I get back to this. And yeah, that's my video.